High inside the Arctic Circle, in one of the most unforgiving environments on the planet, two teams of paleontologists investigate a 70-million-year-old mystery. They've unearthed dozens of dinosaurs, adults and juveniles. Their bones jumbled together, fossilized, then locked in permafrost for eons. Until now.
Well, there's two pieces of bone right here. It's as if somebody took 15 pachyrhinosaurs, dumped them in a blender for 30 seconds, and then poured all of the mess out into a large batch of concrete and let it solidify for 70 million years.
The startling discovery that these ancient reptiles, thunder lizards, lived and thrived in the Arctic has taken scientists by surprise.
It challenges everything that we think we know about dinosaurs.
Finding polar dinosaurs was important because it provided whole new insights into the biology of dinosaurs.
How did they survive in such an extreme environment? And what was the real reason they were driven to extinction?
There's a lot of questions out there, and it's not as simple as everybody died because a rock came in from space.
Fire in the hole! From millions of years in the past, a story of survival against all odds from Arctic dinosaurs, right now on Nova.
Major funding for Nova is provided by the following. ExxonMobil, taking on the world's toughest energy challenges. And by David H. Koch. And
discovering new knowledge. HHMI.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
Early March, Alaska's North Slope, the frozen Colville River. A team of scientists has pitched camp here at the base of these cliffs, willing to brave the perilous polar winter to investigate a startling discovery.
There it is. The hadrosaur looks like the base of the tail. Success.
They've unearthed dinosaur bones near the North Pole. The animal is called Edmontosaurus, a gentle giant. A 35-foot-long, 4-ton, duck-billed plant eater. A member of the hadrosaur family found in 70-million-year-old rock, a mere 50 miles from the Arctic Ocean, where temperatures can drop as low as -60 degrees Fahrenheit. According to conventional wisdom, it shouldn't be here, because this is how dinosaurs are typically pictured. Cold-blooded reptiles living in tropical climes, not in cold Arctic environments like this one. And the hadrosaur is not alone. In two sites along Alaska's Colville River, paleontologists have recently unearthed 8 distinct species, represented by hundreds of fossils.
On this table are examples of the biodiversity of the animals, the vertebrate animals that we found up on the North Slope. And we have a variety of meat-eating dinosaurs. And this is the left front jaw, an animal called Gorgosaurus.
30 feet long, almost 3 tons, nearly a match for its fearsome cousin Tyrannosaurus rex. Gorgosaurus was at the top of the food chain. In competition, Troodon, 6 feet long, 150 pounds, small but ferocious, and Dromaeosaurus, a wolf-like two-legged hunter, which may have had feathers as insulation.
And here we have a horn core from our Pachyrhinosaurus.
A massive 4-ton plant eater with a broad, bony frill protecting its neck, an elongated skull with a beaked mouth, and a thick bone above the nasal opening. Pachycephalosaurus, a two-legged plant-eating brute with a thick, bony dome on its head, possibly used for combat or defense. And Thessalosaurus, another two-legged animal thought to be a plant-eater. The unexpected discovery of so many species living in the Arctic is leading scientists to rethink old assumptions about dinosaur biology.
The traditional view was that dinosaurs were all overgrown reptiles that lived under tropical conditions. When we found polar dinosaurs, however, it was driven home to everyone that dinosaurs could live under very different and thrive under very different climate conditions.
Scientists long believed that dinosaur biology resembled that of cold-blooded reptiles, like crocodiles, animals that require warmth to survive and cannot withstand prolonged exposure to temperatures below freezing. But not one crocodile fossil has been found along the Colville, which suggests that polar dinosaurs found a way to adapt to an environment that their cold-blooded cousins couldn't tolerate. But how? Luckily for the scientists, many important clues are preserved in the rock. When these animals died, layer upon layer of sediment covered their bodies. Minerals slowly replaced bone tissue to create fossils. Then, 45 million years ago, geologic forces began to uplift the ground, exposing the edge of the fossil layer along these frozen cliffs.
Well, there's two pieces of bone right here. And there's another piece of bone.
I think that's definitely the bed.
And there's enough bone in here already that would indicate that this very well may be the Liscum bed.
It was here in 1961 that Shell Oil geologist Robert Liscum came across a large fossil. He sent the specimen back to his office, intending to have it classified by a paleontologist.
Unfortunately, Liscum died the next year in a rock slide. So they were in a Shell warehouse until about the mid-1980s when Shell was cleaning house, and they sent them to the USGS. There, a paleontologist by the name of Charles Repenning found the bones and immediately recognized that they were dinosaur bones.
Now, scientists Tom Rich and Kevin May are about to go deeper into the Liscum bone bed than anyone has ever attempted.
My gut feeling is that it's going to go a lot further back than 3 to 4 meters. That black layer could very well be the fossilized layer.
With the help of seasoned Alaskan gold miner Bobby Fithian, they will spend the next month blasting a tunnel into the permafrost. Once inside, they will dig down into the bone bed, the rock layer where fossils, if they're there, lie packed together, protected from the elements. They begin with a set of relatively small charges.
Fire in the hole!
The goal is to open a passageway about a foot above the fossil bed, but no closer. The worry is that if they don't angle the blasts just right, they'll destroy the treasures they came to retrieve.
Take a look at this.
Distal tibia.
That was found right down here, at this level here.
So far, they seem to be right on target.
It's a good start.
Blasting for fossils is an unusual way to do paleontology, but not for Rich. He was one of the first scientists to discover polar dinosaur fossils, not in Alaska, but at the opposite end of the world.
I don't mean to pat myself on the back, but as far as trying new techniques, and it worked. 20 years ago, I cut a tunnel. I cut a tunnel in Australia.
There, he used dynamite to expose a narrow fossil layer buried deep in the rock. That bone mine yielded thousands of fossils, mostly well-preserved small pieces, proof that 100 million years ago, dinosaurs lived near the South Pole, an environment even colder than this one near the North Pole, where he's trying again to find dinosaurs.
I mean, we've got small bone in here. Look at this.
Where?
Right in here?
Yeah, this little.
Paleontologist Kevin May has searched for fossils all over Alaska, but this is his first tunnel. And he's excited by the hadrosaur bones that are beginning to be exposed as they go deeper.
This is exactly what we came here for. This is the best I've ever seen this stuff. I just am blown out on this one.
Yeah, so we don't need to go deeper. We just need to go straight in at about this level. Give yourself maybe 10 centimeters above what is obviously a fossil layer into this stuff.
The initial digging to establish the entrance to the tunnel has already unearthed some large bones.
That's definitely a rib.
But most are in poor shape.
Some type of long bone here. Unfortunately, it's fairly well powdered.
Because they were lying close to the surface, the fossils have been broken and worn by the freeze-thaw cycle, the punishing effect when water seeps into the ground and then expands when frozen, cracking open rocks. The purpose of the tunnel is to dig deep into the permafrost, which is not prone to those seasonal changes, and hopefully find better preserved, smaller, and more delicate bones.
When we get in, what we hope 20 meters, we're going to be beyond that. So we're going to see bones for the first time that's never been through that.
With the entrance set safely above the fossil layer, they give Bobby Fithian the go-ahead to complete the blasting. When they're finished, the tunnel stretches a remarkable 65 feet into the cliff, laying bare rock that hasn't seen the sun for tens of millions of years.
We're going to finish securing the tunnel and supporting this brow.
The team has successfully completed the first phase of their project. The delicate work of excavating the bone bed will begin in 5 months' time, during the Arctic summer when the weather is milder and the sun remains above the horizon nearly 24 hours a day.
There isn't any reason for this tunnel not to be here at least 100 years from now if you take care of it.
Okay.
You've got a nice tunnel. You're going to find some dinosaurs.
Oh, yes.
Good job, buddy.
For Tom, this is the culmination of years of struggle.
Dr. Rich?
And he knows that without the skills of the Alaskan miners, it could never have come to pass.
I'd like to thank all of you. You know, you guys have helped me achieve something I've been trying to get to for 18 years.
Though the goal this time was merely to build the tunnel, their work paid an unexpected dividend. Hadrosaur bones. These duck-billed plant eaters appeared about 145 million years ago and were one of the most successful groups living, right up until the time that all dinosaurs died out, around 65 million years ago. Hadrosaurs may have owed their success to several important adaptations. They were one of the first large animals to evolve fleshy cheeks and hundreds of teeth that were continually replaced, features that made it possible for them to chew their food instead of just biting and swallowing, as other creatures did. They also built nests and apparently tended their eggs, like brooding birds. Hadrosaurs are the most common dinosaur found at the Liscombe bed. But 28 miles upriver from the tunnel, atop a 300-foot cliff, a second team of paleontologists has made another remarkable find. A mass grave containing at least 4 species of dinosaur, including Gorgosaurus, Edmontosaurus, Troodon, and Pachyrhinosaurus.
This is the most diverse assemblage of dinosaur bones here on the North Slope. It's got a variety of kinds of animals. It's got tremendous bone density. There's an abundance here like would never have believed.
Tony Fiorillo and his team are doing paleontology the old-fashioned way, with picks, shovels, and grim determination.
There's some sites I've worked in the lower 48 where a chimpanzee with a popsicle stick can work the localities. This quarry is not one of those localities.
It's late summer, but this hardly feels like a vacation. The treacherous climb, the frozen ground, the freezing rain are a daily trial. But it's all been worth it, because Tony has just found the crown jewel of the Colville. A massive skull, flattened but otherwise intact.
This is the right side of the face.
It takes a trained eye to see the shape embedded in the rock, but to Tony, it's crystal clear.
This is the skull of a horned dinosaur. It's upside down. So you're looking at the right side, or the right cheek, of something that we've been calling Pachyrhinosaurus.
Pachyrhinosaurus, the horned dinosaur, a relative of Triceratops, previously known only to live much farther south. And there are others.
There's 14 individuals of a horned dinosaur in this little pit so far.
Finding so many Pachyrhinosaurus in one spot is like stumbling onto an elephant graveyard. 70 million years ago, something happened that deposited the bodies of more than a dozen massive animals in this one spot. The river below offers a clue.
The density of bone's so high that it's easy to envision this being a jam in a river channel. These animals were transported downriver somewhere, and presumably they created their own little log jam, except there was a bone jam in a river channel.
But as long as the skull remains in the ground, there's little that Tony can learn from it. So the team is working to remove the half-ton piece of rock that encases it, so that they can transport it back to their lab in Dallas, Texas. Step 1, dig out the skull without breaking it.
Is move some of this rock out of the way here and up here.
Encase it in a protective jacket made of burlap and plaster, and then airlift it to safety. That's the plan. But nature isn't cooperating.
Right now, the weather is killing us. It's mid-30s, it's snowing, and we're in the Arctic. And so mixing plaster in this kind of moisture and with snow and high humidity, it's problematic. On 3. 1, 2, 3. Watch it. We'll plaster that hole over, and then we can hoist it out with a chopper.
When the helicopter arrives, they worry that the plaster hasn't fully cured.
What do you think?
It's not giving off any more heat. So it's hydrated, it's hardened as much as it's going to get.
But the helicopter is on a tight schedule. It's due to deliver its load to an airstrip further upriver. From there, the skull will travel by plane to Fairbanks, and then 4,000 miles by truck to warm and sunny Dallas.
Keep our fingers crossed.
Tony knows he's made a big find. But because rock surrounds the skull, he doesn't know yet the condition of what's inside. So when the jacket arrives in Texas, Tony's colleague Ron Tchaikovsky quickly begins the painstaking work of removing the debris that surrounds the large skull. He's almost immediately surprised. The rock around the skull is filled with bones, bits and pieces from more than one Pachyrhinosaurus.
A wonderfully intact vertebra, part of the spine of this animal.
This bone is of particular interest. They've already found several others at the same site, but until now they weren't completely sure which dinosaur species it belonged to.
This is the point where the skull attaches to the first vertebra of the neck in a beautiful ball and socket joint. And we have at least 15 of these from this particular quarry. It's as if somebody took 15 Pachyrhinosaurs and dumped them in a blender for 30 seconds and then poured all of the mess out into a large batch of concrete and let it solidify for 70 million years. Everything is completely jumbled about, bones are oriented in all sorts of different directions, and nothing's connected.
Finding so many Pachyrhinosaurus tells Tony that these wide-ranging animals, found throughout North America, lived in large numbers on the North Slope. But the bones don't say how they lived, or what conditions were like during the toughest time of year.
What did they do during the winter time? How was life up here the same or different than what we see in the lower latitudes?
Scientists have long known that the Earth's climate was generally warmer during the time of the dinosaurs. But how warm was the polar climate 70 million years ago? Was it hot enough to be considered tropical? And were the seasons as extreme as they are in the Arctic today? British paleobotanist Robert Spicer may have solved one important piece of the puzzle with the help of ancient plants.
When I find a fossil leaf, it tells me something. It's like a messenger from the past.
He made his first trip to the Colville River in 1976.
It was known that there was a rich flora there, but what I didn't realize was just quite how abundant it was. So we'd land and run over to the outcrop and start hammering away, and there were the leaves.
Since then, Spicer has amassed one of the world's most impressive collections of Arctic botanical fossils from the late Cretaceous.
This collection here is fairly typical of the kind of fossils we find throughout the late Cretaceous of the North Slope. Now, what we have here is a 90-million-year-old cycad.
Cycads are tropical and indicate warm conditions.
This one here, this is a conifer.
Conifer trees are found in a variety of climates. Measuring up to 30 feet tall, they were common on the North Slope.
This is a fern. These are the sorts of things that your knees would brush past as you walk through the Cretaceous forest. This here is quite unusual. It's a leaf which has got a smooth edge to it. It hasn't got any teeth. And this is typical of the kinds of leaves that we tend to find in warm environments today.
As his collection grew, Spicer had a hunch that he could use these leaves to deduce the temperature of the Arctic 70 million years ago. It was an idea based on a simple observation that allowed him to decode the secret language of leaves. In hot tropical climates, the edges of leaves are smooth. But in colder climates, they tend to have serrated edges.
Well, when we look at leaves such as these, you can see that the edges of the leaf have got teeth on them. It's very jagged. And in fact, if you look at any of the tree species around here in this relatively cool climate in the UK, you'd be very hard pressed to find a significant number of leaves that have got smooth edges to the leaves.
Spicer believes that these serrations evolved to help plants circulate water and nutrients. In hot climates, moisture evaporates from leaves, causing water to rise up through the roots. But if the temperature drops, evaporation and circulation ceases.
Now, in those situations, the plant can't evaporate water from the leaf, so it can't suck water out from the ground. And of course, the plant needs the fluid going through the plant body to move nutrients.
But the serrations in leaves growing in cool climates solve that problem, because at the tip of each tooth is a small gland that aids circulation.
So in a cool environment, the plant actively pumps water out through the teeth.
The real breakthrough came when Spicer realized that he might be able to pinpoint the temperature of the late Cretaceous using his fossils.
It's the proportion of toothed leaves and non-toothed leaves that we see in a particular place living today or in a fossil assemblage that gives us an idea of the relative warmth, the average annual temperature during the year.
He and his team spent years comparing leaf shapes to climate data in more than 170 locations around the world. It was a massive undertaking. But in the end, he was able to create a statistical model that ties leaf tooth patterns to temperature.
We can tell what the average annual temperature was at a given place to within plus or minus 1 or 2 degrees Celsius, which is, when you actually look at it in detail, is about as precise as many modern-day meteorological observations are.
When Spicer examined his fossil collection, he discovered a match between those ancient Arctic leaves and leaves found today in southern Alaska, a temperate climate, very different from the barren tundra today. The model indicated that the average annual temperature on the North Slope was about 42 degrees Fahrenheit, 30 degrees warmer than it is there today. But that number is deceptive, because at high latitude, the yearly highs and lows are far apart. So while the dinosaurs would have enjoyed summer temperatures in the 70s, winters were likely cold enough to produce snow and even ice. On the Colville, summer temperatures are now nearly 100 degrees above the frigid lows of late March. The dinosaur mine has been sealed for 5 months. Now it's time to find out if there's anything inside.
Grab a shovel.
This is not what they hoped to find. The portico built by the miners held up, but the eroding cliff has poured in around the edges, nearly burying the entrance. And there's even worse news.
Well, this is sort of bad news here. Looks like we've got impounded water inside the tunnel. Got water flowing out beyond our vapor barrier. So there must be standing water on the other side of this hole.
During the spring thaw, the river rose an incredible 25 feet and flooded the tunnel.
Oh, joy. Dun, 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 dun.
The bad news is we have a mess.
Yeah.
There is some good news.
No, there's nothing yielding. This is beautiful. That is fine. We're going to be safe in here. There's no yield at all.
The walls and ceiling are frozen solid. It's like standing inside a refrigerator, cooled by million-year-old permafrost. During the winter excavation, the team didn't have time to explore the fossil bed. And now, because of the flood, the tunnel floor is hidden beneath at least a foot of ice. And there's only one way to get it out. It will take days of brute force labor to clear out the tunnel. The outside temperature may be warm enough for the scientists to work in shirt sleeves. But this is not a hospitable place. The river temperature is barely above freezing, and the Arctic landscape is barren. If they were alive today, herds of dinosaurs could not have survived in a place like this. What was their polar summer like 70 million years ago? That's the question that Steve Hasiotis has set out to answer. He's a paleoichnologist.
That's a beautiful sinusoidal trace.
He studies impressions preserved in rock, which are often the only record left by birds, insects, worms, and other animals too small or delicate to have become fossilized themselves.
Well, these are just basically associated with things like horsehair worms.
Using Alaskan fossils from the late Cretaceous, he's cataloging the insects and other animals present in Alaska to measure the diversity and health of the dinosaur ecosystem.
All right, guys, grab some gear. We do it by looking at the similar kinds of traces and scratches and trail patterns made by animals and environments today. And then we can take that information, look for the similar patterns in the rock record.
Today, he's brought some fossil impressions to a riverbank near Lawrence, Kansas. With the help of his graduate students, he will try to match the trails made in the 70-million-year-old rock to those made just days or hours ago by modern animals.
Great trail right there. Holy smokes. I think these are these mud-loving beetles where the ceilings of them have collapsed. Bird tracks here, and then these worm trails here. This is the association that we're seeing up in the Arctic.
From the modern-day animals on the bank of the Kansas River, a snapshot of a very similar environment in ancient Alaska begins to emerge. And he's sharing his insights with Tony Fiorillo.
On this here, you got about 4 or 5 different trackways here and trails, ones that are slightly larger aquatic earthworms. Totally fantastic hopping trails of a grasshopper or a cricket. And this other thing here is a crawling trail that's reminiscent of a beetle.
So we got worms, beetles, and some sort of cricket-like thing. Does that help fine-tune the environment that these things were in?
This had to be probably in the height of the summer or near the end where it's very warm. There's a high diversity, low-lying water. swampy areas. Nice large lake plain or lake margin exposed.
That means a rich ecosystem in the summer, capable of supporting creatures of all sizes, and a much greater diversity of plants and animals than is found in Alaska today.
Picture yourself standing on this lake shoreline. It's warm, sunny. There are herds of duck-billed dinosaurs and other kinds of plant-eating dinosaurs along the lake, eating vegetation like horsetails, ginkgos, the flowering plants. An abundance of flying insects and crawling insects on the shoreline, in the water. Theropod dinosaurs, large ones like T-Rex, smaller ones probably like Troodon, and they're hunting these plant-eating dinosaurs.
The good times of the year, when it was not dark and cool, it probably would have been very similar to what we now see in the southeastern United States, with lots of conifers, lots of flowering plants. In fact, the late Cretaceous, except for the dinosaurs, would not have been an unfamiliar environment to us.
Conditions were mild during the long, bright summer days, but the winter would have been much more challenging. Because they're so close to the Earth's axis, the poles, north and south, experience the most dramatic seasonal changes. At the height of summer, when the North Pole is tilted towards the sun, the North Slope enjoys a month of constant daylight. But in the depths of winter, when the North Pole is tilted away from the sun, the North Slope spends 6 weeks each year in near total darkness. The continents continually drift, and because the North Slope used to be even closer to the North Pole 70 million years ago, the extremes were even more pronounced.
The present location of the Liscum bone bed, that's at a current latitude of about 70 degrees north. At the time the dinosaurs were living, it was closer to 85 degrees north.
Today, the North Slope is 1,500 miles from the North Pole, but 70 million years ago, it was 4 times closer, a mere 350 miles, with 4 months of darkness during the long winter. In thin slices of fossilized trees, Bob Spicer sees how the darkness affected the plant-eating dinosaurs' food supply. Under the microscope, individual cells are visible, showing a pattern of growth rings.
The tree rings show that in the summer, the trees were very happy. They were growing quite rapidly.
The light-colored cells were produced during the bright summer months.
And as the season progresses, the walls get thicker, the color goes browner, until at the end of the growing season, the cells are really quite small. Then we get no more cells. The tree goes into dormancy.
The summer growing season was long and active, but once winter arrived, everything stopped.
Now, what that means is that it was dark and there wasn't a lot to eat.
For plant eaters, the food supply would be reduced to decaying plants, roots, even bark. Hard times. But not necessarily for meat eaters, like Troodon. Troodon may have had an adaptation that would have turned the liability of darkness into a killer's asset. Tony recently found a fragment of a young Troodon skull, which shows that the animal had unusually large eyes and an enlarged optic lobe in the brain.
So the brain would be in this cavity right here. We've just caught the beginning of where that brain is enlarged to accommodate the optic region of the brain.
Troodon's enhanced visual system may have allowed it to hunt at night. And it's not the only species with those features. In 1989, Tom Rich named Dinosaurs, found near the South Pole, another small meat-eater with unusually large eyes. With food scarce, the large herbivores would need to conserve energy. They would have been torpid, sluggish, easy prey. But maybe the plant eaters didn't hang around. Perhaps when the season changed, they struck out in search of better conditions.
There's even the suggestion that some of these animals have gone through annual migrations. It's not inconceivable that these huge herds, particularly of the large plant-eating dinosaurs, migrated over huge distances, much like many modern mammals do today in search of forage.
Migration is an important survival strategy in today's Arctic. As summer ends, caribou herds migrate south to their winter ranges. The distance is about 400 miles as the crow flies. But because the caribou don't travel in a straight line, the journey can stretch to thousands of miles. Dinosaurs would have had an even longer journey. Because the North Slope was much closer to the pole 70 million years ago, to escape the darkness, they would have had to walk 5,000 miles, nearly twice the distance from New York to Los Angeles. According to Tony Fiorillo, some animals wouldn't have been able to make the trek. He's compared the relative size of juvenile hadrosaurs to adults to determine if the young were physically capable of keeping up with a herd on the move.
We argued through a biomechanical analysis of the juvenile duck-billed dinosaurs that they were too young or too small to make any long-distance migration. So therefore, we argued that these animals lived here year-round. That opened up a whole bunch of interesting biological questions, like how did they survive the seasonality?
Tony's evidence has important implications for a long-running debate about dinosaur biology. Were they cold-blooded like lizards, or warm-blooded like mammals? Cold-blooded animals cannot long endure low temperatures. They seek external heat sources to power their metabolisms. Warm-blooded animals can generate heat internally to keep a constant body temperature. And many warm-blooded animals are found in cold climates. And there is strong evidence that dinosaurs were the ancestors of modern birds, which are also warm-blooded. But so far, no conclusive answer about dinosaurs. Kevin May's hadrosaur bone could add clarity to the debate. It's now in a lab in South Africa, where Professor Anyusha Chinsami-Turan is examining the bone for clues about dinosaur metabolism.
And here we're looking at a bone that is 70 million years old. What we see here are these interesting structures that tells us about how fast this bone formed, about the organization of the bone tissue.
The bones of warm-blooded and cold-blooded animals form differently. Reptile bones grow rapidly when conditions are favorable. But when food is scarce or temperatures drop, growth ceases. That start-stop pattern of development leaves telltale markings in the bone, similar to the rings in tree trunks.
These alternating rings of growth that we see in reptiles, they tell us that these animals, their growth is dependent on seasonality.
Birds and mammals, however, grow differently. They are not as sensitive to seasonal changes. they add new layers of cells more rapidly and continuously. In warm-blooded animals, no growth rings. Because the hadrosaur was a dinosaur, and because the poles experienced the most extreme seasonal swings on the planet, Anyusha expected that the bone would show pronounced growth rings. But instead, she had a surprise.
I don't see the growth rings that I would have expected in an animal that would have been affected by seasonal climatic conditions.
The hadrosaur bone more closely resembled the bone of a mammal or bird. That suggests that the hadrosaur did not hibernate or slow down during the winter. It was active all year round.
I suspect that perhaps this animal was very well adapted to the environment in which it lived.
For some scientists, thinking of dinosaurs as warm-blooded is the only explanation that makes sense.
If they're warm-blooded, you can see them surviving in this kind of climate, much as modern mammals and birds do in the Arctic today.
Today, biologists increasingly understand that there exist degrees of warm-bloodedness and cold-bloodedness in the animal world. It's not always one or another. Dinosaurs likely had their own unique solution to the body temperature problem, which allowed them to survive for millions of years in the toughest seasonal conditions their world had to offer. At the height of summer, the sun stays above the horizon nearly 24 hours a day. Work has continued around the clock to clear the debris. Now is the time to find out if the bones buried inside are better preserved than those found in the cliff face. Kevin makes the most of the short time he has left. Jackhammers give way to precision instruments.
We have this frozen, unbroken matrix that we're able to shave off layer by layer, and it's not flaking apart. So you could not do this outside of the tunnel. You couldn't do it outside the permafrost.
Part of the bird, yeah. Half of it broke is probably in here.
So now we get out the mapping.
Almost immediately, the team finds several extremely well-preserved bones, more delicate than any of the bones they found outside the tunnel. Kevin May suspects that they may be from a new species.
Well, it looks like we have two tail vertebrae and then a flat piece of rounded bone here.
It will take years to fully explore the tunnel and to complete the catalog of Arctic dinosaurs. To date, Tony's Pachyrhinosaurus skull remains one of the largest specimens to come from the Colville.
Yeah, it looks pretty good. It is busted up a little bit, so we'll have to keep our fingers crossed. But getting that stuff out of the way, you can really, this is really nicely defined now. I mean, that's a skull.
But despite its poor condition, the skull and all the other fossils miraculously preserved for 70 million years reveal a fascinating chapter in the history of the Earth. 230 million years ago, the Earth was even warmer than it was at the end of the age of dinosaurs. Those conditions fostered a great flowering of diversity, including the evolution of dozens of species which came to dominate the land, the air, the water, and eventually filled every corner of the globe. And then, 65 million years ago, a devastating blow to the planet, a massive asteroid impact. The prevailing theory is that the resulting explosion threw massive clouds of gas and ash into the air and plunged the Earth into a global winter. The theory held that dinosaurs, tropical animals, were unable to cope with the darkness and the cold that followed. But the discovery that dinosaurs already lived in non-tropical conditions and during long periods of darkness suggests that there must be more to the story.
I think that one of the values of our work is that it is suggesting that a catastrophic end to the Cretaceous did not kill off the dinosaurs.
But if the asteroid alone didn't wipe out all dinosaurs, what did? According to the fossil record, 70 million years ago, 5 million years before the impact, the number of dinosaur species around the world was already shrinking.
As we go through the late Cretaceous, diversity seems to decrease. And it's a general truism of evolution that the more biologically diverse you are, the more robust and able to cope with environmental change you are.
Before the asteroid, the writing may have already been on the wall. Continents were on the move. Air and water circulation patterns were changing, causing global temperatures to fall. The planet was slowly evolving into the world we know today, a world in which dinosaurs would not be able to thrive.
I think it's an instance where this huge impact that created the Chicxulub crater on the Yucatan Peninsula of Mexico was basically sort of almost the icing on the cake.
The fossil record cannot tell us how long dinosaurs survived after that terrible catastrophe. But Arctic dinosaurs, far removed from the disaster, could have been among the last survivors in their changing world.
On NOVA's Arctic Dinosaurs website, watch any part of this program, go behind the scenes, and more. Find it on pbs.org. Major funding for NOVA is provided by the following: ExxonMobil, taking on the world's toughest energy challenges. And by David H. Koch. And
discovering new knowledge. HHMI.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you. NOVA is a production of WGBH Boston.
I am PBS.